Hello and welcome. In this video, we are going to take a look at the current P2. Now, this video is not meant to be a comprehensive instructions on how to do P2, but rather sort of give you some hints if you're stumped or perhaps some guidance on how to get started. This video assumes that you have already been successful at setting up your environment with NetBeans, MinGW, have already possibly created a couple of C executables and have ran them from the command line. And ideally that you have watched some, if not all, of the videos about P2 or the older version of P2 as part of the fundamentals demo. So you want to consider this video as a little bit of a hint or a little bit of a primer. Perhaps you're stumped or you'd like just get some guidance on how to get started, or perhaps you just like a little bit of validation that you are doing it the right way. So to begin with, not everything I'm doing is going to be exactly the same way that you are going to do it. First case in point is that I have this P2 .step_01. It's a file that I've just sort of captured some of my progress of when of long, and you will not, in fact, have that in your P2. Instead, what you want to do is you want to focus on your process and sort of take some hints or some suggestions as I go along. So the first thing that you want to do, of course, is to go ahead and create a project called P2, and you want to make sure that you have a source file that has your main in it known as P2.c. Now, I did this, and then what I did is later on is I stopped and created this sort of little temporary file here, this step_01, just for the purposes of showing you some help. And then the next thing I did was I went ahead and downloaded, made sure I had a copy of our instructions, our P2 setup.c, and also the P2 sample.txt. Now, ideally, you would put all of those in one folder. Make sure ultimately that you know where all of them are. And you can see here that I've also downloaded that JPEG that I provided for you. And you can see there are all the files, but you'll notice in the project itself that I only have my P2.c. And that's perfectly okay. The rest of these files, the instructions, the setup.c and the sample.txt don't technically have to be part of the source files for your project. As a matter of fact, if you add some of the files, you may end up getting some errors, so it's better that you don't do that. Instead, what I've done is I've simply just dragged and dropped these into NetBeans. Now, to begin with, let's just take a quick look at these files. You'll see there's the sample.txt file. That's for the input and the output for your executable. We'll talk about that in just a second. The instructions that I've given you, I've broken the problem down into 4 problems. I'm going to give you a brief look at the first part or the first part of the solution, in the words for problem 1. Each one of the problems essentially corresponds to a function inside of your P2. And then I've also given you another little hint here for this project, and then I've went ahead and given you the function prototypes. Now, if you've noticed already, you see that those function prototypes are actually buried in the instructions. So again, I'm trying to give you a little bit of help as you go along. And again, this video is assuming that you've already looked at the instructions on how to do a regular P2 or one of the older P2s. So I'm kind of jumping around a little bit. So the first thing I did is I simply copied over all of the function prototypes. You want to remember that you are supposed to have the function prototypes at the top of the file. They come after your include file. And you can see here in my P2.step_01 that I've done exactly that. So I have my preprocessor directives here, my includes, and then my function prototypes. The next thing I've done is I've went ahead and copied all of these little function stubs over. You'll notice that effectively what they are is there's just simply copies of the prototype minus the semicolon, and then with curly braces, the void output and void input just simply means that no output arguments are returned and no input arguments are accepted. And then I've included a block for the comments. And you'll notice that I've done the same thing down here, except what I have done is I have added some more information in that comment block. In other words, just taken this template and then just modified it to be a little more specific to the function, as well as putting a print statement inside of each one of the functions. Now, I highly encourage you to do this. You can optionally turn these things off after you get done with the executable, but it just creates some noise at the beginning of your development work, so that way you could see that these functions are in fact actually running. It's a really, really helpful debug tool when you're first starting programming. And in some cases, I just simply like to have a little bit of noise on the command line so that you know your executable is actually doing something. The third thing that you'll notice here that I've done in my step one is I've simply went ahead and called each one of the functions here. And you'll notice that I call them by simply using the same line that you saw up in the prototype, minus the input and the output arguments, and then make sure to include the parentheses here and then the semicolon. At this point, you should have a buildable executable. Now, regrettably, because of the way that I'm demonstrating this to you, I can't really build this particular one. This file is not part of the project. Again, it's just sort of an artifact of the process. Now, what I would encourage you to do is just to go ahead and pause the video maybe at this point. I'm going to keep going in just a couple of seconds, talk about the solution. But this way, if you can get caught up to this particular step, the next steps will make a lot more sense to you. So I would encourage you to go ahead and pause here and then come back in a few minutes once you've got yours set up to this level. All right, so now let's take a look at our P2.C. In other words, the one that I've actually been working on and I've already completed for you. As a matter of fact, it's actually what I used to create the P2 sample.txt. You'll notice that I have these nice input prompts as well as the output prompt. In other words, the input prompts are what I want, I want the question that I want the user to see. And you see here that I've also provided some sample input. Now, it's probably not the most creative sample input. I sort of had a method to my madness here. I wanted to check my values, check my equations. And so you can see here that I've used some of the values over and over again. But what I've done here is I've basically tested all four of my functions one after another. Now, you'll see in just a second, that's not actually how you want to go about doing it, but I wanted to create this sample text file for you. You can also see here that I've got these tables mostly lined up. They look pretty good. You could argue the formatting and everything like that could be better. Basically, everything is left justified, and you have 4 decimal places to the right of the decimal point. Again, we talk a little bit more about this in other videos, but I'll show you the format spec that I'm using to create this table as well as the structure for the table. Now, let's go ahead and focus in on one of the functions. I told you earlier in the video, I'm going to give you one of the solutions here so get you started, make sure that you have good success on this first project, because then that'll lead to better success or more success in the future. So practicing the software development method that you saw in one of the earlier videos and sort of this process of systematically breaking down the problem instead of just starting to throw code at it, you'll see that I've basically got this broken up into 5 parts. The first part is where I declare the variables, and specifically, I think about the data type associated with the variable. In other words, we know based on the instructions that I need to collect the radius and the length of this bar or this tube or whatever the cross section happens to be. And I need a reasonable variable to store that value in. And so in this case, I'm giving you some suggestions here. I would like for you to follow these variable names that I've given you in the P2 instructions. And you'll see that basically what I've done is I've created a variable of type double for each of the input as well as the output values. Now, technically speaking, we could bypass some of this, but again, I would encourage you to not do that. And I also do not want to see any really short or confusing variable names. In other words, for these earlier projects, I want you to go ahead and use these variable names that I'm providing. And you'll see that then as a second step, I'm initializing all of these values. That kind of has 2 justifications behind it. Number one is when you declare a variable in C, it is a uninitialized value, or for all intents and purposes, you can consider it garbage. And what do I mean by garbage is that it's an unpredictable value. And we can talk about all of the different possibilities there in later videos. But for right now, what you want to do is know that you must initialize a variable once you declare it. And from there, then what we want to do is we just want to have prompts for the user, a print and a scanf. The printf simply prints a prompt to the user. In other words, something friendly, something useful to explain to the user what they are to do. In this case, I have provided them a prompt that says, please enter a radius with the units followed by a colon and then a slash new line, slash n for a new line. In some cases, you'll see some examples where there are no new line. I don't like that particular approach because it looks a little confusing, a little hard to read. So I like to go ahead and give a new line there so that it pushes then the cursor down to the next line. And the next line, then what we'll do is we'll accept the prompt from the user. Now, this is in fact not a misspelled word. This is the format spec of %LF which allows for us then to store the value that is entered by the user as a double in the variable, or rather at the address of the variable radius. Now, a couple things are going on here. Number one is you're going to have to get good at knowing these format specifiers for the scanf and then also later for the printf. But basically, that just indicates the type of data that's going to be collected from the user. And then the other important thing that you do not want to forget is this ampersand in front of the variable, because basically that is how scanf works. We'll learn a lot more about that in the future, but basically it's saying I want to store the value that was entered by the user at the address of that variable. Again, we do that for the radius as well as the length, because those are the two pieces of information that we need to collect from the user. And again, you want to make sure and pay attention to the data type. In this particular example, it's pretty simple. They're all doubles. But then you go on to calculating the values once you have collected all the relevant information. Now, I won't bore you too much with these formulas because they are pretty much basic geometry, and hopefully I haven't made any mistakes in any of the functions, which we will again take a look at the end of the video. But you'll notice here this particular value, and you're probably wondering where in the world this came from and this function right here. Well, I mentioned it in an earlier video, but we might as well go ahead and mention again that this is the constant for pi. And how do I get access to that? Well, I have simply included my math.h. And just in case you've forgotten how this works, you can just always right click and go to navigate and go to the declaration definition. And you'll see that in math.h is the definition for pi. So again, here, what I'm doing is I'm just simply doing basic geometry formulas here for the radius of, the circumference of a circle. Talk a little bit more about this later on in the video, but the edge face is basically the edge of the cylinder. In this case, it's a solid cylinder. So you want to think of a solid pipe, and the edge of the face is basically just that lip around the edge. So in this particular case, it's going to just be 2 pi times the radius. And why is there the outer 2? Well, that simply refers to each of the ends of that solid pipe. Likewise, with the area of the face, then basically we have pi times the radius squared, and the power function then just allows for us to simplify this. Instead of multiplying radius times radius, it's basically just radius squared. So again, this is the area of one end of our solid pipe or solid bar, and we multiply it by 2 because there's 2 ends to it. Likewise, we can do the same thing with the outer. We can figure out what the area, in other words, the surface area, not including the ends, is for this solid pipe. And in this case, basically what it is circumference times the length. And now you're probably curious why the area inner is equal to 0. And actually, arguably, I should probably follow that up with 0.0 because it is a double. But basically, in a solid pipe, there is no inside for that solid cross section. You'll see the same thing when you start looking at the rectangular cross sections as well, the solid rectangular cross section. And then lastly, the volume of the pipe. And that one's pretty straightforward. Now we get to actually displaying the results. And this is where you can jump back over the p2.sample. And you'll see that I've kind of cheated a little bit. In other words, I've very carefully copied over some of the table to make this nice display here. And I've just simply prefixed it or added the printf, as well as the open and closing parentheses and the semicolon. And again, you can get pretty good at this, pretty fast at this with copying and pasting. It's one of the reasons I like to give you a sample so that you can work a little faster and a little smarter. And you'll also notice here that for each of the values here, I've kept it pretty simple. That is where we are getting the 4 places after the decimal. The F just simply indicates that it is going to be a double precision value that's going to be expected. In this case, you'll see that, of course, I am passing the radius, length, edge, and so on, and those are all doubles. I follow this up with a nice table border, one at the bottom and then one at the top. And again, these are just aesthetics, but I would like for you to follow these aesthetics for these earlier projects. And then at this point, we can just go ahead and build it. And if we've done everything correctly, you should get these successful. Now, I want to point out now we've got a little bit of a problem here. And this is really the last important part of this video. So I'd encourage you to probably stop the video one more time and just go ahead and get your functions actually working before we actually start testing them. because there's a little trick here, and I talk a little bit about it in the other video, in the testing video for the original P2, but I want to reiterate it one more time. I want to show you once more what you've got to do here. And so I'd encourage you to go ahead and pause the video once more and complete the rest of your functions, and then come back. All right, so now to understand what this last step looks like, you've ideally completed all of your functions at this point. You've got your P2 working completely, but there's a little bit of an annoying problem. And that problem is that basically, in order to run this, you actually have to run all 4 of them. And more importantly, that doesn't match up with the instructions that I've given you, where for some strange reason, I've asked you to provide me with 4 different executables. And you're probably wondering how in the world you are supposed to go about doing that. And by the way, I just realized I have a little typo in my P2.c. I'm not really sure how I managed to get that in here without noticing it until right now, but we might as well go ahead and fix it since we are making a video here on things to fix in our project. Let me make sure real quick that it is not the same case in the P2 setup. I'm really not too terribly sure how I've managed to get this bug in here, but let's go ahead and fix it. Great opportunity for us to see one of the tricks in NetBeans here. You'll notice that all of my function prototypes and my functions all say 2D when they were supposed to say 3D. So I'm just going to do a Control H, which is going to highlight all of the 2Ds, and I'm simply going to replace them with 3Ds, and then hit replace all, and then you'll see that it makes all of the changes at once. I'm going to build it one more time just to make sure that I don't have any more problems. And we'll go ahead and close this one. I'm actually kind of amused at that one. I don't know how I managed to make it so far into this video without noticing that. All right, so back to the problem at hand. You're actually calling all 4 functions, which is really not what you want to have happen. Basically, what would happen is you would run this thing, it would finish running Circle 3D version 1, and then it would immediately jump into the next one. So what we want to do is we want to actually turn off all but the function that we wish to call. So in this case, I'm going to turn the last 3 off. I'm going to build it one more time. I'm going to come out here to my command window. I'm going to type in dir, and sure enough, you can see there's my p2.exe. Notice that I'm in my dist debug and mingw Windows directory. Again, if you need a little bit of practice at that, take a look at my earlier videos. But then we're going to go ahead and run my p2.exe, and of course, it's going to prompt me for the radius. If you're probably wondering why, you'll see that it's the prompt then, or that first prompt that we had in our Circle 3D version 1 function. In this case, I'm just going to enter in 1 for the radius and then 10 for the length, much like I did in the sample text file. And you can see there's my table, and then it stops running because, as you see, there's no more code here. Now, the thing is, we don't want the executable to be named P2. So what we actually need to do is we need to come along here, and we want to very carefully rename this. And you can do this a number of ways. You can copy this out of the instructions. You can go back to the folder, into the dist folder, into the debug folder, into the mingw, and then make sure that you have your file extensions turned on. If you've not yet done so, you want to go to View. I'm on Windows 10. The same is true for Windows 11, and roughly similar for Mac. You want to make sure and turn on the file name extensions, and you can optionally turn on hidden items as well. But then what you want to do is either rename it by right-clicking it or hit F2, and then paste the name of the executable that you wish to have. In other words, the name that I have given you in the instructions. And now it is Circle_3DV1. And if you want to prove yourself that it still works, you can just simply come over here to the command window, type in dir, and then Circle3DV1. Bring this over just a little bit here, hit enter. And sure enough, it prompts you first for the radius and the length. And basically, long story short, you've done no changes to the executable. You've just simply changed the name of it. Which brings us back to how do we do the next problem? Well, the next problem is pretty much the same instructions, just a different cross section. And then we still have our p2.c, but I need a different executable name. Well, first thing we do is we turn off the Circle3DV1. We turn on the Enulus 3D v1. We go ahead and build it. And then we come back out here to the command window, and you'll see if I type in dir that magically my p2.exe is back. Well, effectively what we've done is we've recompiled it now with this second function turned on, and you can prove that to yourself by simply typing in p2.exe, and sure enough, you're going to get prompted for the outer radius, the inner radius, and then the length. In other words, you know that that is the one associated with the annulus. And again, I'm assuming that you've already got yours working. And if not, you have to kind of go back and do that before you go any further. But if nothing else, you should have this calling annulus 3dv1 here. You'll notice that it also said calling circle 3dv1 and so on. Now, what we can do is we can simply come back over here to the instructions one more time, borrow the name of the executable with a little bit of copying and pasting, and then come back out here to our folder, and then again rename our p2.exe. Now at this point, I think you've seen what we're trying to do here. You've seen the pattern. You just simply need to do it 2 more times. And at this point, then what you want to do is you simply want to zip up all of the EXEs that you create, as well as the text files. I'll talk a little bit about the batch input file in another video. Basically, what this does is this allows for you to automate the testing process, as well as create a batch file where you can test all of them. So as always, hopefully you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.